Hello students, so we have started synopsis 4 we have studied in earlier lecture. Now we will start worksheet 4 from today, okay. Now CUQ, first question is 7 by 6 factorial. We have to find the factorial of 7 upon 6. Is it possible to find the factor of 7 upon 6? No, it is not possible because factorials are meant for only non-negative integers. Okay, we can only find the factorial of non-negative integers, means from 0, 1, 2, 3, 4 up, okay, not negative integers and not proper fractions, improper fractions, okay. We cannot find the factorial of fractions or negative numbers, okay. We can only find the factorials of non-negative integers. So 7 by 6 factorial is not defined. It is not defined. Okay. So the option is fourth one. Now second one is also like that. What is second question? It is minus 5 factorial. Is it possible to find the factorial of minus 5? No, it is not possible because it is negative and we cannot find the factorial of negative numbers, okay. So it is also not defined. Option is does not exist, okay. So the option number is 4, does not exist, okay. Now third question is NC4 equals to 330. Okay, NC4 is given as 330 and we have to find N, okay. We have to find N. Now, do you remember the formula we have written? NCR equals to N factorial upon R factorial into N minus R factorial. It was the first formula we have written. NCR equals to N factorial upon R factorial into N minus R factorial. So according to this formula we can solve, we can calculate the value of N. So here it is NC4, NC4 we will write as it is. Now N factorial means N is not given, we will write as it is N factorial upon R factorial, R is given as 4, here it is R, NCR. So R here is 4, so we will write 4 factorial. Now N minus R means N is not given, N minus R is 4, that is N minus 4 factorial, okay. Now its value is given as 330, so we will write is equals to 330, okay. Now N factorial upon N minus 4 factorial. Now 330, here it is 4 factorial, if I take it here it will be 330 into 4 factorial. If I multiplied 4 factorial to both sides, 4 factorial will get cancelled and 330 into 4 factorial. Now I can write N factorial as N into N minus 1, N minus 2, N minus 3 into N minus 4 factorial. We have written this, okay. We can write N factorial as N into N minus 1 factorial also, N into N minus 1, N minus 2 factorial also, and N into N minus 3, N minus 2, N minus 3, N minus 4 factorial also. So we have written N factorial as this one. So upon here it is N minus 4 factorial, it is equals to 330 into 4 factorial, okay. Now N minus 4 factorial and N minus 4 factorial will get cancelled. Now N into N minus 1, N minus 2 and N minus 3, it is equals to 330 into 4 factorial. If we take the factors of this 330, it will be 11 into 30. 11 into 30 will be 330, but we can also find 330. Factors of 330 also it will be. Okay, we will first factorize it. 2 into 165 is 330. So multiply by 4 factorial. I will take it here. Okay, 330. If we factorize 330, it will be 2 into 165. So again 165 can be divided. 2 into 5, 3s are 15. 5 3s are 15 again. Now 2 multiply 5 multiply by 33 can be factorized as 3 into 11. So now these are prime numbers. So this is the final factorization of 330. So instead of 330, I can write 2 into 5 into 3 into 11 and multiply by 4 factorial. 4 factorial we can write as 4 into 3 into 2 into 1. Okay. Now we have to make part of this such that n, it will be one number will be n, second number will be n minus 1, third number will be n minus 2, fourth number will be n minus 3, because it is equals to this. So let us see which is the biggest number in this. Biggest number is 11. So here it will be 11. Now smaller than 11 is, if I take 11 factorial, I will write 11 into 10 into 9 into 8. Okay. So smaller than 11 is 10. So I can make the pair 5 into 2, 2 5s is 10. So I can write here 10. Okay. Now 10, now we have to find 9. Where it is 9? 3 multiplied by 3 is 9. So I can write here 9. Now again, what should come after 9 in the factorial? It should be 8. So let us see where it is. 4 into 2. Here 4 into 2 is 8. Okay. So we have found the factorial 11 into 10 into 9 into 8. Now we should compare with this n into n minus 1 into n minus 2 into n minus 3. So here it is n is equals to 11. Okay. Now n minus 1, that is 11 minus 1. Here it is 10. 11 minus 2, 9. Here it is 9. 11 minus 3, 8. Here it is 8. So this is equals to this. So according to this equals to this, what is the value of n? And value of n is 11. Okay. So we have found the value of n as 11. So second option is there, 11. Okay. We have just used the formula and put the values of 330. N was not given. We have just put the value of r and calculated, and according to this we have just factorized 330 and 4 factorial and put it according to n into n minus 1, n minus 2, n minus 3. Okay. And we have got the value of n as 11. Okay. Now fourth one, the term independent of x in x plus 1 upon x whole square. Now we have to find the term which is independent of x. So we can easily factorize it. It is the a plus b whole square. What is the formula for a plus b whole square? It is a square plus 2ab plus b square. So we can solve this. So it will be a square, that is x square, plus twice ab, means it is 2 into x into 1 upon x, plus b square here it is 1 upon x. So we will take 1 square upon x square. So x and x will get cancelled. So our answer will be x square plus 2 plus 1 upon x square. Okay. So the term independent of x, which is the term independent of x? It is 2. So 2 is our answer. 2 is independent of x. Okay. Now here it was only 2. So you can just make the expansion and put out the term which is independent of x. But if the power is higher, 9, 10, 11, 12, what will you do? You have to solve by formula, and that formula is ax to the power p plus b upon x cube, x to the power q equal to the power n equals to ncr a to the power n minus r b to the power r. Okay, where and r we have to find first, where r is equals to np upon p plus q. Okay, so this is the formula for finding the term independent of x. Okay, now where r is equals to np upon p plus q. So according to this formula also we will solve. So what is formula? Ax to the power p. First we have to calculate r. So we will calculate r first. So np, here n is equals to 2. Here you can compare this both, this formula and the given question. You can, if we compare this one and this one, n is equals to 2. Okay, so our n is equals to 2. So according to this formula, r equals to np, n is 2 and p is the power of x. So here power of x is 1. So we will write 1. Now p plus q. Here power of x is p. Now in second term power of x is q. Here power of x is 1 and here also power of x is 1. So we will take 1 plus 1. P and q both are 1 in this one. Okay. So it will be 2 ones are 2 upon 2. So it will be 1. Our r is equals to 1. Okay. Now we will put in the formula of NCR equals to, what is the formula? NCR equals to a n minus r b to the power r. Now we have found both n is equals to was given and r is equals to 1. We have found from this formula. So NCR means 2, CR is 1, 2C1 equals to a to the power, here not equals to, a to the power n minus r means 2 minus 1, that is 1, and b to the power r means b to the power 1. So can you solve this 2C1 by which formula? NCR equals to n factorial upon r factorial into n minus r factorial. So here 2C1 is given. Here a to the power 1, b to the power 1. 2C1 is given. We have to find 2C1. So 2C1 will be n factorial. Here n is 2. So it will be 2 factorial upon, here r is 1. So 1 factorial and n minus r means 2 minus 1, that is 1 factorial. Okay. So 1 factorial is 1, 1 factorial is 1, 2 factorial is 2. So we have got the answer as 2. So 2 is the term independent of x. Okay. You can also solve by expansion if the power is less. If the power is higher, you have to solve by this formula only. Okay. Now fifth one, the sixth term in the expansion of 2 plus x to the power 10. Now sixth term in the expansion of this, we have to find sixth term. So we have studied binomial expansion. Do you remember previous lecture? We have studied binomial expansion. What it was? If I take a plus b square, okay, a plus b whole square. What was the formula we have found? It was 2c0 a to the power 2 and b to the power 0 plus 2c1 a to the power 1, power of a was reducing, a to the power 1, b to the power 1, okay, value power of b is increasing. Now plus 2c3, 2c2, now here a to the power 2, a to the power 1, now a to the power 0, and b to the power here 0, b to the power 1, it will be now b to the power 2. Okay, it was the formula for a plus b whole square. Now see here, what was the first term? It is the first term, okay, it was the second term, and it is the third term. Now in first term, r is equals to 0, it is r, okay, NCR, according to NCR, it is n or n and 0 is our r. So r is 0 in first term, in second term r is 1, in third term r is 2, means first term is 0, second term is r is equals to 1, in third term r is equals to 2, okay. So r is reducing by 1 in every term, means in first term it is 1 minus 0, in second it is 2 minus 1, 3 minus 1 is 2, okay. So if we have to find sixth term. So what will be sixth term? So it will be equals to, here n is 10. So I have taken n as 10. Now according to this formula, here it was power 2. So I will write here 10. 10c. Now first term is 0. Second is 1. So r is equals to term minus 1. That is, we have to find sixth term. So r is equals to sixth term minus 1. So r will be equals to 5. Okay. R is always term minus 1. So sixth term minus 1, that is our r. So I can write here r 10 NC r, that is 10c5. Now a to the power n minus r it was. According to formula, what was? It was a to the power n minus r, b to the power r, and according to binomial expansion we have studied in earlier lecture, okay. It is a to the power n minus r. So n minus r, our r is equals to 5. So n minus r means 10 minus 5. So it will be 5, and b to the power r is b to the power 5, okay. Now this is the sixth term, okay. According to formula you have to derive it. Sixth term is r is equals to sixth term minus 1, that is 5, and n was already given, okay. Now we will solve this. What is the formula for NCR again? It is the basic formula, okay, n factorial upon r factorial into n minus r factorial. So according to this, n is 10, so it will be 10 factorial upon r factorial, that is 5 factorial, upon n minus r, that is 10 minus 5, into a to the power 5, b to the power 5. So 10 factorial, I can write 10 factorial as 10 into 9 into 8 into 7 into 6 into 5 factorial. I have just written up to 5 factorial, so I can easily remove this 5 factorial and 5 factorial. 10 minus 5 is 5. Now here it is 5 factorial, 5 factorial, 5 factorial will get cancelled, okay. And what we will get? It was 10 into 9 into 8 into 7 into 6, and 5 factorial and 5 factorial got cancelled. Now 5 factorial is remaining. So I can write 5 factorial as 5 into 4 into 3 into 2 into 1. Now we can cut 5 ones are 5 twos are, now 2 ones are 2, 2 twos are 4, and 3 ones are 3, 3 threes are 9, again 2 ones are 2, 2 fours are 8, 2 ones are 2, 2 twos are 4. Now what is remaining? 3 twos are 6, 6 6 are, now 7 is also remaining. So what is remaining? 3 into 2 into 7 into 6. Now and a to the power 5, b to the power 5 was also there. Okay, a to the power 5, b to the power 5. Now answer is in which form? Oh, answer is not solved. We have to just make the formula. Okay, option is itself in the formula. We have to don't solve it. In the options there was only formula given. That is here a and b are, a is 2 and b is x. Okay, according to this formula we have just option is given on the formula, so we have to just solve up to this. It is 10c5, here a is 2 and b is x. So we have taken 10c5, 2 to the power 5, x to the power 5. So the option is second. Okay. Now level 1, the sum of the coefficients in the level 1 question 1, the sum of the coefficient in the expansion of x plus 1 to the power 5. Okay. Now we have to find the coefficient of sum of the coefficient. We have to find sum of coefficients. So we can easily solve. There is a formula. Sum of coefficients of a plus b to the power n is 2 to the power n. This is the formula. Okay. If we want to calculate the sum of coefficients of, if question is given in this form a plus b to the power n, then we can find the sum of coefficients by 2 to the power n by taking 2 to the power n, where a and b are variables. Okay. So a and b are variables. So it can also be in the form of x plus 1. So here it is x plus 1. So we can easily find the sum of coefficients of this expression by taking 2 to the power n. So 2 to the power n equals to, here n is, compare that one a plus b to the power n, and this one n is equals to 5. So 2 to the power 5 and 2 to the power 5 is 32. So our answer is 32. Okay. So the option is first one, that is 32. Now second question. The middle term in the expansion of x minus 1 upon 2x to the power 10. Okay. We have to find the middle term. Okay. We have to find the middle term of this expand. If we expand it, we have to find this middle term. We can't expand a minus b to the power 10. It will be too complicated. So we have to find the middle term of this. What is the middle term? Now we have taken a plus b whole square. How many terms were there? A square plus 2ab plus b square. There were power is 2 and terms are 3. So always, if you want to calculate the total number of terms, just make the power plus 1, that is 2 plus 1. Here power is 2 and I can make 2 plus 1 equals to 3. So there will be 3 terms in this. Okay. So according to this, what number of terms are there in this expression? It will be n plus 1, that is 10 plus 1. 10 plus 1 is 11. So therefore 11 number of terms are there. Okay. So if you want to find the total number of terms in the expression, it will be always power plus 1, that is here it is 10 plus 1, that is 11. If you expand it, the total number of terms will be 11. So the middle number of 11 is, which is the middle number of 11? 6 is the middle number of 11. Okay. So we have to find the sixth term. We have to find the middle term. So middle term is sixth. So we have to find the sixth term. So sixth term, what was the formula? We have just taken NCR, a to the power n minus r and b to the power r. So for sixth term, what is here? N is 10, power is 10, so n is 10, so it will be 10c. Now r is sixth term minus 1. I have just told you in previous example. It is, if you have to find r, it will be sixth term, that is term minus 1, that is it will be 5. R will be equals to 5. So I can write 10, n is 10 and r is 5. Now a to the power n minus r, that is 10 minus 5, that is 5, and b to the power r is, that is b to the power 5. Okay, and we have to find this term. This term is sixth term. Okay. Now 10c5, we can again solve by that formula n factorial upon r factorial into n minus r factorial. So n factorial, that is 10 factorial upon r factorial, that means 5 factorial into 10 minus 5 factorial. Here a is x, so we will take x, and b to the power 5 means here b is 1 upon 2x. So we will take 1 upon 2x to the power of 5. Okay, that was the general formula, but here a is x and b is 1 upon 2x. Okay. Now 10 x to the power 5, and it will be 1 upon 1 to the power 5 is 1, and 2 to the power 5 is 32, and x to the power 5. Now x to the power 5 and x to the power 5 will get cancelled, and what is remaining? 10 factorial. I can write 10 factorial as 10 into 9 into 8 into 7 into 6 into 5 factorial upon 5. I can write 5 factorial as 5 into 4 into 3 into 2. Okay. Now 10 minus 5 factorial is 5 factorial. So I can cancel 5 factorial and 5 factorial. So what is remaining? 3 2s are 6. This 6 will get cancelled with this. Now 5 1s are 2, 5 1s are 5, 5 2s are 10. Now 4 1s are 4, 4 2s are 8. Now what is remaining? In denominator it is 1, and in numerator here it is also 1 upon 32. This is 1 upon 32. Okay. Now what is remaining? It is 2. I can write it here. 2 into 9 into 2 into 7 upon 32. Okay. Now calculate 9 2 2s are 4, 9 4s are 36, 36 into 7 is, what is 36 into 7? It is 252. So it will be 252 upon 32. Okay, we have to just reduce this once more time. So it can be divided by 252 upon 32. It can be divided by 4. So 4 1s are 4 8s are 32, and 4 6 are 24, 4 3s are 12. So it will be 63 upon 8. Okay. So our answer is 63 upon 8. But here it will be minus. Why it should be minus? Because if the term is given in the form of a minus b to the power n, a minus b to the power n, and power is, and you have asked sixth term, sixth means even number of term. If you have asked even term, then you have to put minus in the answer, okay. If expression is given in the form of a minus b to the power even term to the power 10 and even term is asked, okay. If a minus, here if in the middle it is minus and even term is asked to you, then you have to put minus. Okay. If this is in the form of this, minus is in between and even number of term is asked, then put minus in the answer. If odd term is asked, you don't have to put anything. If even term is asked, you have to put minus here. If here it is minus only, then only. So our answer is minus 63 upon 8, that is fourth option, okay. Now the third one, again the term independent of x in x square minus 1 upon x to the power 9. Now again independent term is asked. Now you cannot expand easily. This is a minus b to the power 9. You cannot expand easily. So we have just taken the formula in CUQ question 4 and you have to repeat that formula. What was that formula? Ax to the power p plus b upon x to the power q to the power of n. It is equals to NCR a to the power n minus r b to the power r, okay. And where r is equals to, where r is equals to np upon p plus q, okay. You have to just use this formula and find the middle term, independent term, which is independent of x. This is the formula for finding the term independent of x. So according, if we compare this and this, so what is n is equals to 9, n is equals to 9 and r we have to calculate by this formula. So n is 9 and p, if we compare this and this, power of x is p, here power of x is 2, so it will be 2 upon p plus q, that is powers of both x is added. Here power of x is p, power of x is q, here power of x is 2 and here power of x is 1. So it will be 2 plus 1, so 9 2s are 18, 2 plus 1 is 3 and it will be equals to 6. So r we have found as 6. You have to just use the formulas only. Now I can write, we have found n was equals to 9 and r we have found by this formula as 6. Now we can put this in this formula. So it will be NCR, that is 9, CR is 6 and again a to the power n minus r, that is 9 minus 6 is 3 and b to the power r means p to the power 6, okay. Now we have to find 9C6 by which formula again? N factorial upon r factorial into n minus r factorial, again by that formula only. Now 9 factorial, what is 9? What is n? It is 9. 9 factorial upon r is 6 and n minus r, that is 9 minus 6 is 3 factorial, a to the power 3, b to the power 6. Now now in factorial I can write 9 factorial as 9 into 7 into 6 factorial and into 8. 9 into 8 into 7 into 6 factorial upon this is 6 factorial, and 3 factorial I can write as 3 into 2. Okay. Now 6 factorial and 6 factorial will get cancelled and it will be, now 3 ones are 3, 3 threes are 9, 2 ones are 2, 2 fours are 8. Now what is remaining? 3 fours are 12, 12 sevens are, what is 12 sevens are? It is 84. So the term independent of x is 84. Okay. So our answer is 84. Now fourth question, the coefficient of 1 upon y square in y plus c cube upon y square to the power 10. The coefficient of y square. Now, how will you find that when is the coefficient of 1 upon y square? Now, how you will find that 1 upon y square is in which term? You can find by NCR a to the power n minus r, b to the power r. Okay, by this formula. Here n is 10, so I can write 10. Now, first term is always 0, start by 0, that is r equals to 0, okay. First term always start with r is equals to 0. So, here r is equals to 0. Now, a to the power n minus r, that is 10 minus 0, here n is equals to 10, okay. Now, a to the power n minus r means 10 minus 0, that is 10, and b, here a is y, okay. That is y to the power 10 and b to the power, here b is c cube upon y square. So, we take c cube upon y square to the power, what is b to the power? Here it is r. So, r is our 0. So, here it will be 0. So, now y square to the power 0. So, it means it will be equals to 1 and y to the power 10 is remaining. Do you find 1 upon y square here? No. So, we have to find the next term. Now, next term will be 10c0. Here r is equals to 0, now r will be equals to 1. So, 10c1, now y a to the power n minus r, a here is y to the power n minus r means 10 minus 1 is 9, and b is c cube upon y square to the power r means here r is 1, so it will be 1. Now again find, here it is y square, it will get cancelled with y square only, and remaining will be y to the power 7, but we want 1 upon y square. So again we will take out the third term. The third term will be 10c2 y to the power n minus 1, that is 10 minus 2, that is 8, and c cube upon y square to the power 2, r is 2. Now check whether it is y square to the power 2, it will be y to the power 4. It will get cancelled with this y to the power 4 and y to the power 4 will remain. but we want 1 upon y square. So again we will take next term. So next term will be here, it was 10c2. So next term will be 10c3. Now y to the power 8. So first a to the power n minus r means 10 minus 3. So it will be 7 and again c3 upon y square to the power r. Here r is 3. Now again, can you find 1 upon y square here? Here y square to the power 3, y to the power 6 it will be, and y to the power 6, y to the power 6 will get cancelled and 1 y will be remaining, but we want 1 upon y square. So again next term will be 10c4 y to the power, now 10 minus 4 is 6 and c cube upon y square to the power r here is 4. Now check whether it is true. Y to the power 2 to the power 4, it will be, what it will be? If I take it y to the power 6 it will be, and this is this is c to the power 3 4 12 upon 5 to the power 2 4 is 8. Okay. So y to the power 6 and y to the power 6 will get cancelled, and what is remaining? 1 upon y square. Here it will be 1 upon y square. Okay. So we have found the term with 1 upon y square coefficient. So this is the term. Okay. In this term we will get 1 upon y square, because y to the power 8 it will be, and y to the power 6, y to the power 6 will get cancelled and remaining is 1 upon y square. So we have to find this one, coefficient of 1 upon y square. Okay. Now 10c4 y to the power 6 and c cube y square to the power 4. So it will be 10c4 and y to the power 6 and y to the power will get cancelled, 6 will get cancelled, and what is remaining? 3 4 12 upon y to the power 2. Okay. We can also write it as c12 into 1 upon y square. So this is the coefficient of y square. Okay. 1 upon y square, and we have to find the coefficient of 1 upon y square. So by solving this we can find, so again by that formula, n factorial upon r factorial into n minus r factorial. So here n is 10 factorial upon r is, here is r is 4, so it will be r factorial, and again n minus r, that is 10 minus 4 factorial c 12 into 1 upon y square. Okay. Now 10 factorial, I can write 10 factorial as 10 into 9 into 8 into 7 into 6 factorial. Okay. Upon 4 factorial, I can write 4 factorial as 4 into 3 into 2, okay, into 1, and 10 minus 4 is 6 factorial, again 6 factorial will get cancelled. Okay. Now let us check if what is dividing. 4 1s are 4, 4 2s are 8, again 2 and 2 will get cancelled, 3 1s are 3, 3 3s are 9 into c12, c to the power 12 into 1 upon y square. Okay. Now again I will solve here. So what is remaining? In denominator it is 1, in numerator it is 10 3s are 30, and 30 into 7 is 210. Okay. 10 3s are 30 and 30 into 7 is 210, and what is remaining? C to the power 12 into 1 upon y square. So now we have found the coefficient of 1 upon y square. What it is? It is 210 c to the power 12. So the option is 4. Okay. Now Remaining we will solve in next lecture. Till now, bye.